Hey there, so as you see I've got 8 different quadrilaterals here. There are, for the most part, the ones you're going to be using in this class. So what I'd like you to do is follow along with me. I'm basically going to create a flowchart, if you will, that classifies each of these quadrilaterals from the least complex at the top to the most complex at the bottom. And by complex I mean it's got a lot of different properties or uniquenesses about them that you're going to want to know in order to move further with the class. All right, so let's go ahead and see what we've got here. We've got our basic quadrilateral, which again, it's a 4-sided polygon. We have a trapezoid, all right? We've got a parallelogram, a rhombus, a rectangle, a kite, and a square. So I know that, well, I assume that the majority of us have heard of these before, so I'm going to go ahead and move forward and forego the intense explanations about these until we actually get to talking about each individual one. So, like I said, I'm going to create a flowchart, if you will, least complex to the most complex. The least complex here, obviously, just based on what it looks like, is going to be this guy here. All right, it's just a 4-sided figure. So I'm going to go ahead and take it and move it here. I'm going to put it right at the top. So again, a quadrilateral, 4-sided figure, that's pretty much it. It's a polygon. So if you remember anything about polygons, it's a polygon with 4 sides. That's all. All right. Now I'm going to go ahead and move on to, let's see, what looks a little bit more complex than our regular quadrilateral. I'm going to go ahead and choose our kite here. Okay? And I'm going to move over here. And our kite, if you look at it, it's a little more complex than the green quadrilateral we have at the top. We've got 2 adjacent sides that are congruent and another set of adjacent sides that are congruent. So that's something new and kind of taking a little bit more as far as the complexity level is concerned. Then we also have a pair of congruent angles, all right? And they're obtuse ones. So the obtuse angles are going to be congruent. We've got 2 adjacent sides that are congruent at the top. We've got 2 adjacent sides at the bottom. And again, it doesn't necessarily need to be oriented like this. We could flip it around this way or whatever you want, and it's still going to be a kite, and it's going to look like that. All right, so I'm going to go ahead and draw an arrow from our green quadrilateral to our orange kite. Okay, least complex. Now we're moving to something with a little bit more. Okay, a few more properties than we've talked about before. All right, so let's go ahead and move on. Let's do some trapezoid action. So I'm going to go ahead and take this one here and kind of compare it with the pink one, which looks, I guess, easier to work with. I'd go with the blue one. Or I guess that could be a little bit lavender. Whatever, it's blue. So we're going to go with the blue one. And I'm going to put it right here. Okay, and a trapezoid, if you notice, has a pair of parallel lines. We actually call those bases. So a trapezoid is going to have 1 pair of parallel bases. Okay, so this is going to be considered a base, and this is going to be considered a base. And again, kind of like our kite, how we orient it doesn't really matter. All right, so just know that it's going to have 2, what we call bases, quote unquote, that are going to be parallel. So it could be here, and these are going to be parallel. These bases here are going to be parallel, okay? And the sides that are not parallel, that we don't consider bases, those are called legs. So this is going to be considered a leg, and this is going to be considered a leg. And there's nothing really special about the legs right now, okay? Something also to notice is that these 2 angles here, these consecutive angles, are going to be supplementary, meaning they're going to equal 180 degrees. So if you're going to see a problem and you've got some sort of algebraic expression, you're going to want to think, oh, supplementary, add them together, set them equal to 180 degrees. All right, that also goes for these 2 angles here, okay? Because these are parallel lines, this can be considered a transversal. We learned that back in the day. So, yeah, there you go, trapezoid. Now, like I said, we're going to go from least complex to most complex, so we're going to go ahead and hit up our isosceles trapezoid. It's got a lot of stuff going on, so I'm going to go grab it. Move it over. Oh, and let's go ahead and talk about it too. So we've got a lot of stuff going on here. What do we notice that's different? Okay, obviously the word isosceles. So what's different than this trapezoid? Okay, and we said that the legs are congruent. That's absolutely right. So we've got two legs that are congruent. It's kind of like an isosceles trapezoid when you've got the two sides that are congruent. Additionally, we have these angles down here at the bottom that are congruent. All right, these are called base angles. Okay, and why are they called base angles? Well, if you remember, we said that the trapezoid has parallel bases, so these two angles down here are going to be base angles, quote unquote. But we also have these up here, and if you remember, when we flipped it around, that's also a base, right? So these are also base angles. Same property applies when you've got, if you're looking at these angles by the legs, these are going to be supplementary because the consecutive angles are supplementary. When we have our parallel lines, we have our leg that is a transversal. That's going to give us some supplementary angles there. All right, and let me go ahead and draw in my arrows. So we've got our basic quadrilateral going to our slightly more complex trapezoid by adding in the parallel sides, parallel bases, and then we're going to add in our isosceles trapezoid, which has the congruent legs and the congruent base angles. All right, so let's go ahead and move on. And now we're moving on to the last four. The last four. We've got a rhombus, a rectangle, a square, and a parallelogram. Okay, based on what we see, I'm going to go ahead and grab our parallelogram as being the least complex of the remaining four because, well, it is. We're going to put our parallelogram here. And let's talk about a parallelogram. Parallelogram. Obviously, it's got four sides because it's a quadrilateral. And these arrows, again, represent lines that are parallel. So these two lines or sides are parallel. These two sides are parallel. So one of the properties of a parallelogram is that the opposite sides are going to be parallel. Okay? I don't have it marked in here because I don't want to get too crazy with the colors and the lines and everything like that. But the opposite sides in a parallelogram are congruent as well. So parallelograms have sides that are opposite and congruent. They also have sides that are opposite and parallel. So those are really key features of a parallelogram that differentiate it from a basic quadrilateral. What else do you see here? Well, if you remember about the little curves for our angles, we've got sets of congruent angles here. Okay, this angle is congruent to this angle, and this angle here is congruent to this one. So if we were going to put those into words, we have opposite angles that are congruent. All right, what else? Looking back over here, we have our parallel lines, our transversal, consecutive angles that are supplementary. We have the same thing here. These angles here are going to be supplementary. These angles here are going to be supplementary, as are these and these. Okay, so again, supplementary, you're going to add them together and set them equal to 180 degrees. Okay, so I'm going to go ahead and draw my arrow in. Now let's go ahead and see what else. More complex, but not too wild and crazy. Let's think, I'm going to pick this rectangle here. All right, and our rectangle actually has very similar properties to our parallelogram, except one key feature that's different. Any guess as to what you see? If you said that it's got all the angles are 90-degree angles or right angles, you are absolutely correct. Okay? So the only difference from or between our parallelogram and our rectangle is that we have the four angles, 1, 2, 3, and 4, are 90 degrees. Okay? The same rules apply as far as the opposite sides being congruent. Same rules apply as far as the opposite sides being parallel. Okay? So that's pretty much the only difference between a regular parallelogram, which you see up here, and the rectangle. All right? Also, the consecutive angles are going to be supplementary as well. So that's, again, a commonality between the two. It is a parallelogram after all. So I'm going to go ahead and draw in my arrow. And I'm going to move along. Alright, so let's look next. I'm going to pick the rhombus, because that is taking it a little bit of a step further as well. Okay, and I'm going to put our rhombus right here. Ooh, I'm glad it fits. Okay, so what's the difference between a parallelogram and a rhombus? Only one thing. The only one thing that's different is that we have all of our sides being the same length. If you remember up here, I didn't mark it, but I did tell you that the opposite sides are going to be congruent. Okay, notice I didn't say all the sides are congruent, just the opposites. So these two again would be congruent, and these two would be considered congruent, because it's a parallelogram, and that's a property of parallelograms. But with a rhombus, all the sides are going to be the same length. So all four sides are equal. That's what this line here means. Okay? Same rules apply as far as the angles are concerned. Opposite angles are congruent. Consecutive angles are supplementary. So we're going to, again, add them and set them equal to 180 degrees. And that's it. That's the only distinction between the parallelogram, really, and the rhombus. So I'm going to go ahead and draw my arrow in, which brings us finally to the square. And not that I saved the best for last, but it's kind of the figure that we all know the most about, right? So let's go ahead and talk, and I'm actually going to draw my arrows in first, and let's think about why I'm doing that. So I'm actually going to draw an arrow from our rhombus to the square and our rectangle to the square. Why would I do that? Well, if you take a look, a square's got properties of both of them, right? So let's look at it. We've got four sides the same, like our rhombus, but we also have all angles being 90 degrees, like a rectangle. So it's got properties of both. So that's why I've kind of drawn the arrows to connect the two, if you will. The same rules apply with the square as far as the parallelogram is concerned, because it is a more complex parallelogram. It's got right angles, like the rectangle. We've got four sides the same length, but we also have, again, like a parallelogram, the consecutive angles are going to be supplementary. Okay, opposite angles are congruent, opposite sides are congruent, and opposite sides are parallel. Okay, so I hope this helps. You pretty much have every single possibility as far as property for the sides and angles in the different quadrilaterals under your belt now. So hopefully this helps, and you'll be doing well in the next quiz or test you have.